My last video got cut off, so we'll finish up the review here. In review, you'll have to characterize your site. You'll have to decide what the generic land use category is for it, and then you'll have to determine the generic water categories if your site has a generic water category. Then you'll have to ensure that you know your soil particle size, and then you'll have to just compare your Tier 1 guidelines or consider your Tier 2. So land and water use must normally be encompassed by one or more of these categories, but sometimes it just isn't. And so, for example, water use not directly addressed by Tier 1 include things like water used in food processing or recreational water. And if you have these and there is no Tier 1 approach for it, you have to move to a Tier 2 approach. So again, here is how you make the decision on whether you're going to use your Tier 1 guidelines, Tier 2, or move from that into something like a exposure control assessment and evaluation and decisions. So let's talk about soil protection using the Alberta Tier 1 guidelines. The Alberta Tier 1 soil guidelines provide a numerical target for remediation of contaminated soil. The background concentration of a substance in soil is defined as the natural concentration of the substance in the absence of any input from any human activities or sources. So sometimes the background concentration of a substance can be a significant proportion of or even exceed your Tier 1 and your Tier 2 guidelines. So background concentrations will vary with your soil parent material, your soil depth, and the hydraulic regime. That's why it's important to take good samples. You need to take care so that you can distinguish between an apparent background concentration that's a result of diffusion from an anthropogenic or a human source and a true natural background condition. So what are the types of parent materials that we can look for? Igneous, sedimentary, and metamorphic rock, or it could be a little bit more specific where you're talking that it came from glacial till, or it's aeolian, or maybe colluvial, like a rock fragment that travels downslope from gravity. The hydraulic regime includes surface water, overland flow, rivers, lakes, and wetlands, but also the relationship between the rainfall and runoff, flooding, and groundwater base flow. For example, surface soils in urban areas that have variable levels of PAHs from cars, that can be considered background based on the definition, but a polyaromatic hydrocarbon contaminated site for an industrial activity is going to have a different background if it is on something like the industrial site rather than the urban site. And this is the importance of determining our land use. Potential receptors and their exposure to soil contaminants are affected by the land use. For example, exposure to workers at an industrial site is going to be different than, say, exposure to toddlers at a day home. The industrial site will have a lot higher exposure limits since it would be assumed they have proper protection measures in place. Different receptors are found in the forest compared to urban commercial property. And so that's why it's very important that we have to determine our land use. But what do you do when a contaminated site borders a really sensitive land use? So even though the contaminant concentrations may meet appropriate guidelines for the less sensitive land use, mobile substances may migrate to the adjacent property. So those concentrations will end up exceeding the guidelines for the more sensitive land use. When a contaminated site does border that more sensitive land use, use the more sensitive land use and apply that to your contaminated site anywhere within, say, 30 meters of the more sensitive boundary. Soil contamination interacts with air and water. Soil remediation guidelines have been developed to protect groundwater quality as well. So, for example, soil contamination, sometimes it will volatilize within the air, but there are times when it will dissolute and leach into the groundwater or run off to surface water. And in this kind of investigation, what we need to do is recommend the concentrations in our Tier 2 that we would want to use. Mobile source soil contamination adds contamination to the air and to the water. And so mobility of our contaminants is super important. We've talked about this before. For all land uses except natural areas, the soil remediation guidelines have been developed to protect indoor air quality. Now, why do we not have that for natural areas? It's because natural areas are not considered to have residences or outbuildings on it. But all of the other types of land uses do have buildings on it. And because of that, the contamination can go through the soil and eddy underneath the building, causing gaseous soil contamination to enter into, for example, a basement. That's a very typical thing to happen. Tier 1 guidelines can be used to help evaluate chemical concentrations resulting from the mixing of byproducts or organic materials. But Tier 1 guidelines are also used to evaluate just the chemical concentrations in the soil. So what does this mean, basically? It means that wastes, industrial byproducts, compost, they can all be land treated if it improves our soil quality. So for example, gasoline, diesel fuel, jet fuel, and kerosene, if registered in accordance to the legislation, they can actually be sprayed on site because it should make the soil better. Now, pesticide guidelines have been developed that we have to follow, and then we followed the D50 for our drilling wastes. Groundwater protection using the Alberta Tier 1 guidelines. Groundwater is a public resource relied on for drinking water, and so the goal of the government is to prevent groundwater from becoming contaminated. Domestic use aquifers are essential, and so drinking water pathways cannot be excluded under the Tier 1 guideline approach. Groundwater remediation guidelines provide numerical targets for the remediation of contaminated groundwater. This should be familiar as it's very similar to the soil goals, but background concentrations will be specific to the groundwater zone, and this will vary over space and time. So, for example, sometimes groundwater flow will change direction over an area or fluctuate with the seasons. The water guidelines that we have are developed to protect indoor air quality, plants, soil invertebrates, and water quality. Groundwater guidelines include a point of compliance, the spatial location in an aquifer where the groundwater quality guideline must be achieved to protect at one extreme. The compliance point could be established at the point of exposure, like drinking water. So, what we're looking for is a human and ecological receptors where the groundwater quality will go, and to meet other conditions such as industrial use or groundwater management guidelines. So, for example, groundwater aquifers used for livestock and irrigation would have a compliance point everywhere within the relevant livestock watering aquifer that exists below agricultural or grazing land. But ecological receptors must be protected at key exposure points. So for aquatic life, the point of compliance is the point of groundwater discharge into a water body capable of supporting an aquatic ecosystem. And for terrestrial receptors, it's everywhere within the shallow groundwater zone and at the point of ground surface discharge. We have to keep in mind that all of our environmental media or matrices are connected. Environmental media like soil, groundwater, air, it's all connected. Soil might leach into pore water and volatile compounds in the groundwater. That might actually volatilize at the water table and move into the soil and into a building above, or soluble contaminants in a groundwater can be transported laterally with groundwater flow and potentially enter a surface water body like a creek, a slough, or a lake. How do we know which land use category to use? Let's go through the definitions of them. Again, we've got natural areas, agriculture, residential parkland, commercial, and industrial. Natural areas are defined as being away from human habitation and activities. So, for example, Alberta's forested lands. Forested lands that are specified as grazing leases, they represent a special case that require an amendment to the normal scenario. Whereas on grazing leases, livestock soil ingestion and protection of groundwater for livestock pathways has to be addressed. Then we have agricultural lands that have a primary use of growing crops or tending livestock as well as human residents. This is also considered habitat for resident and wildlife that is in transit between different habitats and native flora. A farm residence is assumed to be present anywhere on agricultural land. We have residential/slash parkland, which has a primary use of resident or recreational activities. This includes campgrounds and urban parks, but not wildlands. Urban parks are frequented by wildlife, and these exposure pathways have to be addressed. So examples include wildlife in the town of Banff, for example, or just deer in your local park. Commercial land have a primary use of unrestricted access from the public. Shopping malls, daycares, churches, hospitals, but these do not include operation where food is grown directly in the soil. Industrial land has a primary use of production, manufacturing, or construction of goods. This is generally somewhere where public access is restricted. For example, typical factories in an industrial park, children, for example, aren't permitted to just walk into CF. Water uses are linked to land uses through definitions of the land use categories. The 4 generic uses of groundwater or surface water affected by groundwater discharge are human consumption, aquatic life, livestock and wildlife watering, and irrigation. So what does this mean? You apply them when you have it on your site. And that's the end of the lecture for you guys. It's been a real joy teaching you, and I wish you all the best.